Bismillahirrahmanirrahim. Assalamu alaikum. This lecture is for BBA 2. The subject is Business Mathematics. This is our lecture number 8, which is delivered by Ms. Zahra Arif. In this lecture, we will discuss about the logarithm and the laws of logarithm. Logarithm. Logarithm is the mirror image of an index. Look, if m is equals to b raised to power n, then log of b m is equals to n. The log of m to base b is n. What is this? The log of m to base b. The b which is on the little one, on the right hand side of the log as a subscript. Then m is n. If y is equal to x raised to power n, then n is equal to log xy. The log of y to the base x is n. For example, 1000 is equals to 10 raised to power 3. Then 3 is equals to log 10, 1000. What is it? We are writing it in the upper notation. That log of 3 is equal to log of base 10, 1000. Log of 1000 with base 10. Another example is 0.01 is equals to 10 raised to power minus 2. Then minus 2 is equals to log of 0.01 with base 10. Evaluate the following. Let x is equals to log of 3, 9. Now here what is it? The log of m to base b is n. ऐसे था, then m is equals to b raised to power n. Here what we will see that the log of 9 to base 3 is x. What is it? The log of 9 to base 3 is x. Then what will happen? That 9 is equals to 3 raised to power x. So 9 is equal to 3 into 3 is 3 square. So x is equals to 2. Means how many times that 3 is equals to 9. So 3 into 3 is 9. So it means that we have to take 2 as a power. So that would be our x. Another example, x is equals to log 4, 2. The log of m to the base b is n. Then m is equal to b n. Substituting the values in it, the log of 2 to base 4 is x. Then what it means? 2 is equal to 4 raised to power x. Now x is in the power. We need to find that how many times of 2, मतलब कितनी इसकी पावर होनी चाहिए, तो वो 4 आएगा. What we will do, let's see that 2 is equals to under root 4. If we take under root of 4, that will come 2. It means that under root 4 is what? Under root 4 is 2. So it means 4 raised to power 1 over 2. That is 2. So x will replace by 1 over 2. So it means the value of x is 1 over 2. Using rules of indices, the following rules of logs apply. Log of x multiplied by x cross y is equal to log of b x plus log of b y. What is it? That if it is of base b, then you will write b. If it is of base 10, then you will write base 10. In exponential, we have read about the base b, but in logarithm, we will mostly talk about log of base 10. So log of base 10, 2 cross 3 is equal to, because they are multiplying, when they are multiplying, the rule of law is that if the two digits are multiplying, they will be added together in a separate log. So log of 2 multiplied by 3 is equal to log of 2 plus log of 3. Then if second number is, if two variables are dividing, then what rule it will be applied? That it would be in a minus term. For example, log of x over y is equal to log of x minus log of y. Or we can say that log of 3 over 2 is equal to log of 3 minus log of 2. Afterwards, log of x raised to power m. Whenever in a log, a variable comes in the power, what will happen? A variable or any number comes in a power. What we will do? When we will take a log, that power will multiply with the log. What will happen? That power will multiply with the log. Look over here. Log of x raised to power m is equal to m log of x. Or we can take another example. Log of 3 raised to power 2 is equal to 2 log of 3. I am not pronouncing this 10 log of 10 because a general log is normal logarithm, that is of base 10. That is why I am not saying it again and again. Next, from the observed rules, it follows that log of b1 is 0. Log of b1 is 0. Since equal to or greater than 1 is bx, then hence x must equal to 0. Log of 10 1 is equal to 0, and therefore log of 1 over x is equal to minus log of bx. Look, log of 1 is equal to 0. Always remember that log of 1 is equal to 0, and log of 1 over 3 is equal to, because 3 is going in the denominator. When 3 is going in the denominator, it means when we will take it into the numerator, then its power would be minus 1. It would become log of base 10 3 raised to power minus 1, and the minus 1 will come in the beginning of the log. Second is log of b is 1. When the base and the variable both are same, then the value of the log would be 1. B will cancel with the b. Next, log of b nth root of x. When it is nth root of x, it means that it is x raised to power 1 over n, and when 1 over n is in the power, that 1 over n will come in the beginning of the log. A note of caution: all logs must be to the same base in applying the rules and solving for the values. It means when we are solving the log, all log would be of same base. It shouldn't be like this, that one log is of base 10, the other log is of base 3, the other log is of base 2. All of the logs should be of the same base. The most common base for logarithm are logs to the base 10 or log to the base e. Normally we use the log of the base 10, that is known as normal log, and the other with the base e, that is known as natural log. So log to the base e are called natural logarithms. Log of x is equal to natural log of x. If y is equal to exp exponential of x, then it is e raised to power x. If y is equal to exponential of x, it is written as e raised to power x. When it is in exponential form, we will take log of base e. What we are going to do? We are going to take logarithm of base e is equal to y is equal to x. Then it would be called as natural log of y is equal to x. What is natural log of y is equal to x? Features of y is equal to a raised to power x. Non-linear, always positive, and as there is an increase in x, get increase in y, and the slope of graph gets steeper. If x increases, y will also increase, and the slope of the graph will also increase, and it becomes steeper, steeper, and steeper. Logs can be used to solve algebraic questions when the unknown variable appears as a power. For example, find the value of x. 200 multiplied by 1.1 raised to power x is equal to 20,000. What we will do? First of all, we will divide 200 on the other side, then 1.1 raised to power x is equal to 100. Now, we can clearly see that x is in the power. When x is in the power and we need to solve for the value of x, what we will do? We will take log on both sides. So taking log on both sides, log of 1.1 raised to power x is equal to log of 100. So with the help of rule number 3, that if the variable is in the power, then variable will multiply by the log. So what it will become? It will become x multiplied by log of 1.1 is equal to log of 100. Example number 2, solved for x. X is equals to, that is the point number 2, that log of 100 over log of 1.1, no matter what base we evaluate the logs, providing the same base is applied both to the top and the bottom of the equation. By solving it, what we get? 48.32. We can also check the answers by putting the value in the left hand side of the equation and check it with that whether it is equal to 20,000 or not. So it becomes 20,004. So it is approximately near to 20,000. Another example. Find the value of x when 5 raised to power x is equal to 2, 3 raised to power x. Now we can clearly see that this power is on of variable x is on both sides, on the left hand side and on the right hand side as well. And in the right hand side, the other rule is also applying, that two quantities are multiplying. What we will do, rewrite the equation so x is not in the power. Take logs of both sides. Log of 5x is equal to log of 2 multiplied by 3 raised to power x. By rule 1, what will happen? A log of 5x is equals to log of 2 plus log of 3 raised to power x. What we have done in rule 1, if two quantities are multiplying, then it would be appear as plus. And the rule number 3 says that the power will be multiplied with the log. So according to rule number 3, x multiplied by log of 5 is equal to log of 2 plus x into log of 3. Now solving it for x, what we will do, we will find the value of the log using the calculator, and simplifying it, it will come 1.36. We can also check it by putting the values in the given question and simplify it, the answer, that whether the left hand side is equal to right hand side. If it is so, then it means that our answer is correct. Look, this is an economic example. 1. Y is equals to y. Y means output over here. This is Cobb-Douglas production function. Output is a function of capital and labor. A capital alpha, labor beta. So y star function of lambda k and lambda L raised to power alpha and beta. So what we will do, y star is equals to A capital alpha labor beta, lambda alpha lambda beta is equals to y lambda alpha plus beta. What we have done, we have just simplified it, that y is the function of A k L. So A k alpha L beta will come as a y, and lambda alpha and lambda beta will come as it is, but both with the same base, so that is why their power is adding. Constant return to scale says that alpha plus beta is equals to 1. Increasing return to scale says that alpha plus beta is greater than 1. And decreasing return to scale says that if alpha plus beta is less than 1, then it would be decreasing return to scale. This is important for an MCQs. Next, homogeneous of degree R if function of lambda x comma lambda z is equals to lambda r, function of x z is equal to lambda ry. Homogeneous function if by scaling all variable by lambda can write y in terms of lambda r. An economic example 2. National income is equal to 30,000 million pound in 1964. It grows at the rate of 4% per annum. Y income is 10,000 million pound in 64. What is it? Let its unit is in 10,000 million pound. So what will we write? That it is 3, and we have said that it is increasing by 4%. So it means that after 1 year it would be 1.04 times 3, and again after 1 year what would be it become 3 times 1.04 raised to power 2 in 1984. So it means that we are directly jumping from 64 to 84, directly jumping in 20 years. So what we will write? 3 times 1.04 raised to power 20. Compute directly using calculator or express in terms of log. We can use it, solve it by the help of calculator, and if we do not have the calculator, we can calculate it with the help of logarithm as well. So log of y is equals to log of 3 plus 20 log of 1.04. So simplifying it, what we get, that y is equal to 6.5733. So as it was in 10,000 pound as a unit, so we have multiplied the y 6.5733 by 10,000. What we get, that y is equal to 65,733 million. Now, rules of indices and logs. Some practice questions. These are some practice questions. This is first slide and this is the second slide. You have to solve all these questions. Ask me if you need to ask any questions, any query, and send it back to me. Thank you.